Hi, this is Olivia with Prepaze with our last episode in our scientific notation series. And today we're going to be talking about multiplying and dividing numbers in scientific notation. So here's my problem. I am going to be the person who needs to do this calculation. I work at a nature preserve, and I'm trying to figure out how many bananas I need to order for a week of feeding all of the squirrel monkeys in my habitat that I'm responsible for. So I know that each monkey needs 60 bananas over the period of the week, and there's 1,400 monkeys total in the nature preserve. So I need to multiply 1,400 monkeys times 60 bananas per monkey in order to figure out how many bananas to order. Let's practice with multiplying with scientific notation. So to represent each of these values as scientific notation, remember, first we need to pick a representative number between 1 and 9.9, and then multiply it by the power of 10 in order to resume it to its original value. So for bananas per monkey, it would be 6 times 10 to the first power to get 60. And then for 1,400 monkeys, it would be 1.4 times 10 to the third to get 1,400 monkeys. Now let's multiply these pieces together. Recall from last video that multiplying by powers of 10 is very similar to multiplying fractions together. And in the past video, we were adding and we needed to find that like denominator. But recall that when you multiply fractions together, you don't have to do anything special. You just multiply the denominators together and multiply the numerators, keep them both in your calculation, and you're all set. We're going to do something very similarly here. The equivalence of our numerators in this situation is going to be our representative numbers. So 6 times 1.4 is going to be multiplying our numerators together. And then for our denominators, or our powers of 10, we're going to be multiplying those together. Recall one of our properties of exponents is if we're multiplying two powers that have the same base, we add those powers together. So 10 to the first times 10 to the third is the same thing as 10 to the 1 plus 3 for a total of 10 to the fourth. For division, we're going to be doing a very similar thing. Remember that with fractions, division is the same thing as multiplying to a negative exponent. So you would just use the property with division instead of, when you have the same base, you are subtracting the exponents from each other as opposed to adding them together. But for this situation, we're multiplying, we're adding our powers together to get 10 to the fourth, and then 6 times 1.4 is 8.4. So great news, our representative number is still between the values of 1 and 9.9, and then using our multiplying powers rule, we just added the exponents together as long as they had the same base. We end up with 8.4 times 10 to the fourth. Now let's do a quick practice on converting our values that we have in scientific notation to an actual value. So we have 8.4, and what multiplying by 10 to the fourth is telling us is to move our decimal place over 4 places. So 1, then we've got an invisible 1, 2, 3. So my calculations are telling me I need to order 84,000 bananas in order to feed all the monkeys on my nature preserve. So powers of 10, remember, are linked very closely with our decimal places. We've got our ones, tens, thousandths place, our tenths, thousandths, hundredths places. Everything is all interconnected, so this is just a review. And don't let those exponents intimidate you. They're just like fractions, and they follow all the fraction rules. So thanks for tuning in today, and catch you later.